Good afternoon. I am Imani Daniels, and this is my presentation on databases for Cyber 4220. Databases is our next service topic, and the next thing we'll be configuring for our machines. We have been asked to research PostgreSQL for information and ways to harden this service. First, I'll talk a little bit about what Linux databases are and why we use them. When we talk about databases in Linux, we are referring to any database that was specifically designed for the Linux operating system. Databases that are on a Linux distribution can run on both a physical or virtual server. These have usually been configured to run at optimal levels that can work on the open source operating system. When compared to other OSs, Linux tends to offer other advantages to using its operating system. Since Linux is based on the Unix language, databases have the option of being more customizable. However, this means that they can lack the ability of being functional when on a standard server. Linux hosts that hold databases tend to be acknowledged for their reliability. Databases are also useful in Linux because Linux is a generally more secure language than Windows. This allows for a higher rate of permissions that needs to be met before access to any data is allowed. The Linux database is flexible in that the kernel is open source, which makes tool utilization easier. You can use Linux databases for separating information based on a set of permissions so that information is only seen by those who are authenticated to see it. This helps secure information while also keeping it from being edited or removed. PostgreSQL is an object relational database that is open source and can extend to the SQL language. It comes with a variety of features that can store and scale complex datasheets. PostgreSQL was first developed in 1986 as part of the Postgres project at a California university. It is known for its reliability, data integrity, architecture, and the dedication of the open source community. PostgreSQL is utilized to help those who want to build applications while also having the capabilities of protecting the authenticity of data. PostgreSQL can create a fault-tolerant environment which can help manage data of any quantity or size. PostgreSQL allows users the ability to create their own data types, build out custom functions, and it even allows for different programming languages to be utilized. Now we can move into what PostgreSQL is, what functionality it can provide, and how to install it while hardening it for our servers. Here are a couple PostgreSQL features. This includes disaster recovery. Features for disaster recovery include the capability of write-ahead logging, also known as WAL, and replication. Other features for disaster recovery include point-in-time recovery, which is also known as PITR, as well as active standbys and table spaces. For concurrency, the features included are indexing, table partitioning, and MVCC, which stands for multi-version concurrency control. Another feature of concurrency is just-in-time, or JIT, compilation of expressions. For data types, PostgreSQL features primitive, structured, document, geometry, and custom data types. As far as data integrity, the features that PostgreSQL provides include a unique but not kill, primary keys, as well as foreign keys. PostgreSQL features security authentication that includes GSSA API, SSPI, LDAP, and various other forms of authentications. For the PostgreSQL install, PostgreSQL can come on Ubuntu by default, but to grab the install manually, you would use the command sudo apt-get install PostgreSQL -12. The 12 behind the PostgreSQL specifies a version for which is going to be installed on your machine, or instead of using the PostgreSQL -12, you can just use sudo apt-get install PostgreSQL. Using that command will download the latest version of PostgreSQL. This installation includes numerous add-ons and tools to help fit better for your use. Once you install PostgreSQL, a user was created. You then want to switch to that user and type the command psql. A prompt will appear, and you can interact with that the same way you would to issue queries in normal SQL. PostgreSQL hardening. One way to harden your PostgreSQL is by changing firewall rules to specifically allow traffic on the PostgreSQL port. The PostgreSQL port is TCP 5432 by default. You can then save any firewall rules that you have made to your IP tables with the command sudo iptables -save. Another way to assign TLS, or transport level security. PostgreSQL supports TLS or SSL, which is the secure socket layer. And PostgreSQL also has ways for you to incorporate it into the security for the service. Lastly, you can use a database level security, which works off user permissions, so you can specify who can access what databases and alter the rules of the service. Also, you can use reverse tunneling, which utilizes an SSH port forwarding feature. You can start this by using the command SSH -f -n -T -R 5432 localhost 5432 your user at client.host, which will have to be made accessible from the PostgreSQL node. To make it so that you only accept connections to the local subnet, you would use the command iptables minus uppercase A, uppercase input, TCP minus lowercase m, state minus state, uppercase new, dash dport 5432 minus s, insert your local IP address, minus j, uppercase accept. This creates a firewall rule to allow this specific IP connection. As an extra hardening tip, you can also utilize certificate-based access. This means you can use an X509 certificate for authentication instead of regular means. And these are my references. Thank you.